All right, so this is a check your understanding for topic 7-8, which is exponential models with differential equations. Just in case you've forgotten this, or it's been a while since you looked, or whatever. Remember, the important idea is dy dt is equal to ky. When this comes up, it's because we were told in the word story problem, the rate of change of a quantity, whatever this word changes, is proportional to the quantity. So the rate of change is proportional to the quantity, and k is the constant of proportionality. Exponential growth or decay model. Growth happens when k is positive. Decay happens when k is negative. dy dt equals ky has solutions in the form of y equals y sub naught, which is the initial condition when t is 0, e raised to the kt. So it always looks like this. It's really straightforward. All right, let's see what we can do. So a kitten weighs 85 grams at birth. During the first 4 weeks after birth, its weight in grams is given by a function w, which satisfies the differential equation dw dt equals kw, where t is in days and k is a positive constant. Which of the following could be an expression for w of t? So in other words, after doing all of the work, which one could be a solution? Take a look. 4e to the 0.126t plus 81. Amazon dismiss. 13t plus 85. 85 equals e to the 0.059t, and then last 0.446 t squared equals 85 plus 85. Okay, so which one of these is in the right format is really all we're asking here. So take a minute, make a decision. It is C. This is an exponential plus an initial condition. We're not going to be dealing with that kind of initial condition where C ends up back here. This is a line. This is a quadratic equation. This is exponential. That's not there. Notice that 4 and 81 make 85. So they are trying to mislead you with A, but A is the only other valid choice. But it's not, because that plus 81. And it's not proportional. There's your proportionality, right? So proportional means you can't add this. If you remember, it's kind of a 7th grade topic. We're talking about proportionality. And it's a line that goes straight through the origin. This is not. This is funky proportionality, but it's still the same idea. Okay, let's take a look at our next problem. The rate at which the drug leaves the bloodstream is proportional to the amount in the bloodstream. A dose of 40 milligrams of drugs is administered to a patient after 4 hours. Approximately this many milligrams remain. The amount of the drug in milligrams after the person's T is write an equation. Okay. Sorry, not reading that clearly. So I'm going to write my equation. I'm going to start with this first part. The rate at which a drug leaves the bloodstream is proportional to the amount in the bloodstream. So therefore, A for amount, dt equals K times A. Ta-da. So my initial condition A of 0, the amount that was taken is 400 milligrams. Okay. And I know that if I go through the process of doing all the differential equations work, so here's the part that makes this faster, is then you don't have to, because you can just jump to an answer, is that A of t is going to equal 400 e to the kt. The initial condition ending up right here after doing all the manipulation, that's what's going to happen every single time when you start like this. So that's a huge shortcut. Huge. But if you don't remember, you can go through the process and get there, which is great because I don't remember everything. It's too much to remember. So differential equations won't let you down and you'll get here. But if you can go faster, right? Go fast, go slow. So now we need to figure out what K is. And that's where we use this piece of information. 2 hours, approximately this. So A of 2 is 376.7. So now we need to figure out K. All right, so 376.7 equals 400 e to the 2k, excuse me, not 2k. I'm replacing t with 2. Let's see about solving that. We're going to divide by 400. So 0.376.7 divided by 400. And I'm going to write down the whole decimal. Again, to help me avoid any weird things with my decimal place, not being in the correct moment, all that stuff. E to the 2k, natural log of both sides, will give me 2k from this side, equals the natural log of 0.94175. And so k equals that natural log divided by 2. So ln of the answer divided by 2 is negative 0.030. All those zeros. Okay. And so my equation in the middle here is A of t equals 400 e to the negative 0.030 t. So this work led to this answer. And that's my answer. Ta-da. Okay. So again, don't forget the shortcut. It's awesome. Okay, the population grows according to the differential equation. Also notice exponential before I go on. Exponential decay, because it's negative, which makes sense because the drug is leaving the system. It's not gaining momentum in the system like a virus would, or a bacteria where it would grow inside of you, a patient. It's going down. Okay. The population P grows according to the differential equation. The rate of change of P with respect to time is K of P, where T is in years and K is some constant. If the population of the city doubles every 12 years, what is the value of K? This is a little weird, but we can still find K from this. The population doubles. Okay, so first, let's take P. We know that P equals P sub naught e to the kt. Poet, almost. Not pocket. But, so the initial population, whatever that is, they didn't tell me. So whatever that is, e to the kt. Okay. What is K? So the population is doubling every 12 years. So I know a population will be twice as big 12 years later. So whatever this is, let's say it's 50, this is now 100 in 12 years. If this is a million, this is 2 million in 12 years. That's what they're saying. So P divided by the initial population needs to equal 2. And so that's what happened there, because it says the population doubles. And so the population doubles implies this. Okay? That P, that the population at time, whatever, divided by the initial population will be 2. Okay? All right. So let's figure out what K is. And so we're taking the natural log of both sides. And so K is equal to the natural log of 2 divided by 12. ln 2 divided by 12, 0.05776. Or you can stop at 7, whichever one you want. Okay. And so now it wants to know how long will it take the population to triple. So if the population is tripling, P, the new population, so P at T equals 12. So this is going to be P triple Okay. P divided by P sub 0 needs to equal 3 now. So 3 equals e to the k 0.058. And again, I should really use ln 2 divided by 12. So I'm going to use that. No, not like that. I hate it when fractions are exponents. It's so much harder to write. Okay, ln 2 divided by 12. And we're just going to solve for t. Okay. Again, we'll take the natural log of both sides. And so ln of 3 is going to equal this stuff's all going to come down. ln 2 over 12 times t. Multiply both sides by 12. 12 ln 3, and also divide by ln 2 equals t. So calculator. Is about 19. So about 19.020 years. So I don't actually have to know what the population is to answer this question. And that's weird, right? But because they're telling me what the ratio is going to be, double and triple, I can do the math without knowing. Okay. All right. I hope that was helpful, and we'll see you guys soon. Have a great day.